Okay, we're back for section 1.1 of Math 196, Spring 2014. This is video 4 on linear inequalities and equalities. We don't want that. Don't want that either. We want my pen. There we go. Okay, so linear inequalities, that's problems 1, 2, 11, 12, 17, 18. You should be reasonably familiar with these. And the basic rule for solving equations, right, so we have an equal sign in there, is do the same thing to both sides. This is a little bit different than a expression, simplifying an expression, because we have an equation, not just an expression, which is like the thing on the left side is an expression and the thing on the right side is an expression. So I've got this equation. How can I solve this for x? The goal is isolate x. We want to get x all by itself. The first thing we want to do here, step 1, is clear out the denominators. I don't like fractions, and I want to get rid of them. So, denominators. And what do I need to do? Well, what would be the common denominator? Now, I've got a 3, a 5, and a 6. Denominators are 3, 5, and 6 equals 2 times 3. So what are the factors that I have here? I've got one factor of 3, one factor of 5, one factor of 6, but the 6 is a 2 and a 3. So the only factors that I really have are 3, 5, and 2, because this 3 and the 6 is repeated there. So my least common denominator would be 2 times 5 times 3, and that's 30. Okay, but rather than having everything in a fraction, what I can do with this 30 is multiply both sides by 30. So if we multiply both sides by 30, what do we get? 30 times 2/3 x plus 4/5 equals 30 times 1/6 x minus 2. And again, what we've done here is we've multiplied both sides by the same thing, and so that leaves the equation unchanged. Now when we multiply 30 by 2/3, well, 30 divided by 3 is 10, times 2 is 20, so we get a 20x. And 30 times 4/5, well, 30 divided by 5 is 6, and 6 times 4 is 24. 30 divided by 6 is 5, so we get a 5x there, and 30 times minus 2 is minus 60. So what am I going to do now? Subtract a 24 from each side. Well, what I want to do is isolate x. So we'll subtract a 24 from both sides. Right? And 24 minus 24 is 0, minus 60 minus 24 is minus 84, and then subtract a 5x from both sides, and we'll get a 15x equals minus 84. And then finally, we can divide both sides by 15. And that can be simplified a little bit. Right? You can divide top and bottom by 3. And you get minus 28 over 5. So that's solving inequality. And the goal is to isolate the x. And I cleared out the denominators first. Got my numbers on one side, got my x's to the other side, and divided. Okay. Linear inequalities, like problems 3, 4, 19, 20, 23, and 24, are pretty much the same, right? You use the same procedures to solve linear inequalities as you use for linear equalities, except for one special case. If you divide or multiply both sides by a negative number, you have to switch the order of the inequality. So here we have an inequality. I really want to do the same steps to be able to solve this for x. I want to isolate the x somehow. So what I'm going to do is clear out the denominators. And my two denominators are 3 and 4. and they have no factors in common. So if I multiply them together, I'll get 12. What can I do with this 12? Well, if I wanted to get my fractions together as fractions, I'd have a common denominator of 12. But since this is an equation, I can just multiply both sides by 12. Well, it's an inequality, right? It's not an expression. I guess that's the important point. So 12 divided by 4 is 3. 12 times 2 is 24. And then I get a less than. 12 divided by 3 is 4. Times 2, that's an 8x. And 12 times 3 is 36. And now we want to isolate the x. How do we do that? Well, let's subtract a 24 over to the right side. Right, so subtract 24 from both sides. 36 minus 24 is 12. And then we'll subtract an 8x from both sides. And that will give me a minus 5x is less than or equal to 12. And now to get the x all by itself, we divide both sides by minus 5. But remember, if you divide by a negative number, you have to switch the inequalities. So when we come back down here, we divide it by minus 5. So we have to isolate the x greater than minus 12 over 5. Now there's a type of way to write these solutions that some of you may have seen. I'm happy with this. That's a fine solution. But you could write it as that. This is called interval notation. We're looking for x's, all numbers that are greater than or equal to minus 12 fifths. What are those numbers? Well, minus 12 fifths to infinity. Any number between minus 12 fifths and infinity works. Minus 12 fifths itself works. That's what this equality here is for, and that's why we use a square bracket to indicate that we're including minus 12 fifths. Of course, infinity isn't a number, so we have an open bracket there. Either notation is fine. I prefer this actually because it tells me what the inequality, what the letter is. It's x. This doesn't have the x in it. Okay. So, graphing solutions to inequalities. So inequalities, again, you can solve them pretty quickly. The same way you solve equalities, you can, since they have a letter, we can actually graph the solution on a number line. So this is a inequality that's got three sides to it, one there, and then a middle, and then one there. And as long as the x stays in the middle, you can solve it just the same way you did the previous problems, but just, whatever you do to one side, you have to do to all three sides. So what can we do with this? We'll subtract a 5 from all three sides, but we'll state what our goal is. So we'll subtract a 5 from all three sides. 2 minus 5 is minus 3. 17 minus 5 is 12. And now we can divide all three sides by 3. Minus 1 is less than or equal to x is less than 4. Or in interval notation, right? So a bracket here tells me that I want to include the minus 1 because of the inequality, and a strictly less than means I don't include the 4. So that's open there. And we can graph it, right? What we're interested in here is all the numbers between minus 1 and 4. So here's minus 1, 0, 1, 2, 3. Here's 4. We'll just change to red for a moment. We want to include minus 1 and not include 4, so we'll put an empty circle there and then say we want all the numbers between minus 1 and 4. So any number between minus 1 and 4 solves this inequality. Right? If you plug in x equals 0, for example, you'd get 2 less than or equal to 5 less than or equal to 17, and that's true. So any number between minus 1 and 4 would work. An open circle corresponds to an open bracket, corresponds to a strictly less than. A closed circle corresponds to a closed bracket, a less than or equals. And so there is a graph of a solution. And here's another example. We'll go back to black. Isolate x again. So in these three term ones, the x has to stay in the middle. So what do we do here? Well, we'll subtract a 2. And that gives me a minus 6 less than minus 8x less than or equal to 16. And then we'll divide through by minus 8. And of course that means switch the inequalities with a big exclamation point. So I get 6 over 8 is greater than x is greater than equal to 16 minus 16 over 8, right? So this is a minus divided by a minus, so the minus signs cancel out. Positive divided by a minus means we keep the minus sign. And if we simplify that a little bit, we get 3/4 is bigger than x is bigger than minus 2. And then we can graph it, of course. This is an interval notation. And then we can graph it. We want to start at minus 2, minus 1, 0, 1, and 3/4 will be in here somewhere. And we'll go back to a red. We include minus 2. We do not include minus 3/4, and we include all the numbers between minus 2 and 3/4. So there's our graph of the solution. This, of course, is the x-axis, or the real number line. And what numbers are we interested in? The numbers between minus 2 and 3/4, including minus 2, but not including 3/4. Okay, so solving inequalities is pretty straightforward. Same as solving equalities. Just switch the inequalities if you divide or multiply by a negative number. Okay, what else is in section 1.1? Word problems, everybody's favorite. So, the general rule of thumb about word problems. The last sentence will tell you what it is you're trying to find. Once you find the last sentence, you can give it a letter. Usually we call it X or Y, but you can call it whatever you want. And once you've got the letters, then you can start building equations. And once you can build equations, you can solve the problem. So this is really what the goal of a word problem is to be able to take a problem, figure out what the unknowns are, give the unknowns some letters to say this is this unknown, this is that unknown, and then build some equations out of the data that you're given, and then try and solve for the unknowns. So we'll go back to my black pen. Problems 47, 48, 49, 50, they don't have a formal name. I just call them 2 piles of stuff problems. So in all these problems, you have a big pile of stuff. Right, money in a parking meter, money invested into accounts. One of the problems is about ticket sales. And you split the pile of stuff into 2 piles, and then there's some kind of conditions that the pile of stuff has to match is the equations you're looking for. So here's a typical problem. You have $750,000 to invest and 2 funds that you can invest in. Fund A returns 8.2% annually. Fund B returns 6.4% annually. For various reasons, tax reasons, you want an annual interest income of exactly $52,500. So how much should you put in Fund A? How much should you put in Fund B? Again, look at the last sentence. What are you looking for? Well, some of my money goes in Fund A, some of my money goes in Fund B. So, we'll call the money that we put into Fund A X. And X is in dollars, right? It's the amount of money, the amount of dollars that I put into Fund A. So, how much then is in Fund B? Well, I have $750,000 total, right? So, in Fund B, I have $750,000 minus X. And this is how I always start every word problem. I declare my variables. X equals this, and then you write it out in a sentence. And then here's another condition, 7/50 minus X. That's the money in Fund B. Okay, so now we know how much money we have in Fund A. We know how much money we have in Fund B. What else do we know? Well, we know the return for Fund A and for Fund B, and we know how much we want in annual interest income, and we want $52,500. So let me put in a little note here. Percentages means multiply by the decimal. So how much interest do you get from Fund A? Right? How much income? Well, how much money do you have in it? You have X dollars, right? That's money in Fund A. What percentage of that do you get in interest? Well, 8.2%. Right? So the money that you have times the interest rate, that's your interest income. So 0.082x. That's the interest that I get from Fund A. What's the interest that I get from Fund B? It's the same thing. The money in Fund B, that's this. So 750,000 minus X times what the interest rate from Fund B is, which is 6.4% annually, so 0.064. So that's the interest from Fund B. So total interest income equals interest from A plus, and I'm abbreviating that because I don't want to run out of space. Great, so the total income that you get has to be the interest that you get from Fund A, that's this amount, plus the interest that you get from Fund B, that's this amount. And how much are you actually getting in interest? Well, you want exactly 52,500. So now we have an equation. 52,500 equals the interest from A, 0.082x, plus the interest from B, which is 750,000 minus x times 0.064. So if we distribute this 0.064 to these two terms, we get 52,500 equals 0.082x plus, now 750,000 times 0.064 is 48,000 minus 0.064x. Subtract the 48,000 from the 52,000, you're left with 4,500. 0.082x minus 0.064x is 0.018x. Divide by sides by 0.018 and you get x equal to 250,000. So that's how much money in Fund A, and that means 750,000 minus that is how much you have in Fund B. Okay, so again, look at the last sentence, figure out what your variables are. So percentages, we saw a little bit of a percentage here, right? Percentage means multiply by a decimal. So the interest, for example, is the amount of money times the interest rate expressed as a decimal. So problems 53 and 54 involving percentages. Marking something down when you're selling something by 15% means you take 50% of the value off. You subtract it off. Marking up by 15% means you take 15% of the value and add it on. So as an example, a furniture firm buys chairs $125. That's the wholesale price. They buy it from whoever the manufacturer is. they mark them up by 60% to find the retail price. So they buy them for 125, they sell them for 60% over that, and then 2 months later, if they're not moving or if they just want to get some traffic in the store, they mark the retail price down by 20% for a sale. So what is the retail price and what's the sale price? So again, there's two questions here. What is the retail price? What is the sale price? And what is the retail price? The retail price is how much they bought it for plus 60% of what they bought it for. So they actually don't need any letters here, right? So this is what they bought it for. This is the 60% markup. So when you get a 60% markup, you multiply by 0.6. And 60% of $125 is $75. So it's $200. They sell it for $200. Right? And so they're getting $75 profit on it. What's the sale price? This is marking it down by 20%. So we start with $200 and you subtract off 20% of that $200. Right? 0.2 times 200 is $40. So you're taking $40 off and you're selling it for $160. So even with the sale price of 20%, they're still making, well, what's that? $35 on each chair, because they get them for $125 and they sell them for $160. The wholesale price is how much someone buys it, how much someone pays for it when they buy it from the manufacturer. The retail price is how much they charge for it in the store. Okay, so again, percentages multiplied by the decimal. And marking it up is adding percentage, marking down is subtracting percentage. So 5758, again, this is another percentage problem. So this person is working at some store or something, get the $4,000 base monthly salary plus 4% commission on all sales over $5,000 for the month. How much does the employee have to sell in order to make $8,000 a month? Okay, so what's going on here? There's some employee, they get paid $4,000 a month regardless of what they do. They get 4% of their sales over $5,000. So if they sell $5,000, they get no commission at all. They get no extra money. If they sell $10,000, then they get commission, but only on that last $5,000, right? Not on the first $5,000. So, back to my red ink. How much does this employee have to sell in order to make $8,000 a month? So, right, how much in sales? Oops, that shouldn't be an X. That should be an S. In sales. Question mark. Okay. Well, they need $4,000 in commission. Right? Because they get a base salary of $4,000, but they want to make $8,000. That means they better be making an extra $4,000 in commission. So, how much do they need to sell to get $4,000 in commission? Well, we'll say X, which is an unknown thing, right? How much in sales? The amount of sales the employee has over the amount of sales the employee has over $5,000. So this is the amount of sales that the employee gets commission on, right? So it's the amount over $5,000. Then they need $4,000, right? Because that's how much they need to be 0.04x. This is their commission. Oops, let's not go quite down that far. Right? So they get 4% of how much they make sell over 5,000. So 0.04 times X, the amount that they sell over 5,000, is how much they make. So they need that much. So X is 4,000 over 0.04, which is $100,000 in sales. So if they make $100,000 in sales over 5,000, then they will make $4,000 in commission. They need to sell $105,000 a month to make $8,000 total a month. Right? So the 5,000 is because they don't get commission on the first 5,000. Then the other 100,000, they get $4,000 commission on that, plus the $4,000 that they make in their base salary. That gives them $8,000 a month. And finally, a break-even analysis. This is problems 59 and 60. So, a publisher for a new book figures fixed costs at $84,000 and variable costs at $1.90. That should be $1.90. I forgot to put in the dollar sign there. For each book published. The book is to sell at $7.15 to retailers. So, how many books must be sold to break even? So, this is pretty straightforward about what they're looking for. I'll just say X is number of books sold. Okay. Great. Black ink. Okay, so break even, what does that mean? Well, if you're running a business, revenue, that's the money coming in, equals costs. Right? That's what your break even is. It's when the money coming in equals the money going out. If you've got more revenue coming in, then you're making a profit. If you have more money going out, you're making a loss. Okay, so what are the costs here? Well, fixed costs is $84,000. If you're publishing books, you need to do promotion for the book. You have to have ink, you have to have paper, you have to have binding, you have to have a factory that runs it. You need to pay rent on that factory. There's all sorts of things that go into making a book. Some of these are fixed, some of these are variable. So salaries, the factory, the rent, all those things are fixed costs. And that's $84,000. Variable costs, $1.90 for each book. So that's $1.90 per book. So what's my variable cost? My variable costs are things like the ink for each book, the binding for each book, transportation for each book. The more books you make, the more it costs. Each book costs $1.90 in whatever these things are, ink, paper, etc. And so if X is the number of books you're selling, then, or making, then 190 times X is how much you have to spend to make those X books. And $84,000 in sunk costs. What's your revenue? Well, you're selling them at $7.15 each. So $7.15. We don't need the dollar sign there. $7.15 for each book times X, which is the number of books. So you get $7.15 for each book times however many books you sell. That's how much revenue you have coming in. And break even then is revenue equals costs. So revenue equals cost to find your break-even point. 715x equals 84,000 plus 1.90x. So we'll subtract the 1.90x from both sides, and we get 5.25x equals 84,000. And of course, this is your per book revenue, this is your per book cost, this is your per book profit, right? For each book you sell, you get $5.25 in profit. You've got $84,000 sunk into this book. How many books do you have to sell to recover that? If you make $5.25 on each book, well, solve for X by dividing by 5.25. and that ends up at being 16,000. So you have to sell 16,000 bucks, and then you will get your sunk cost back. So break even, revenue equals cost. All these other previous problems, well, the previous three problems, these are involving percentages, percentage of commissions, percentage of wholesale price, of retail price, and this is percentages of interest rates. But in every time when we're dealing with a word problem, look at the last sentence. The last sentence is often the one that tells you what it is that you're looking for, and